Okay, welcome to statistics. Statistics is all about data and distributions, which means where the data is relative to each other. Okay, that kind of makes sense. So, our first day, we're going to be exploring distributions with graphs, or how to show a distribution. Okay, so everybody, important things, individuals versus variables. Individuals are objects described by the data set. Individuals may be people, but they may also be animals or things. When we talk about experiments, we'll call them experimental units or subjects. Subjects only applies to people. But when we're talking about data, we're just talking about them as individuals. They do not have to be human beings. A variable is a characteristic of an individual. A variable can take different values for different individuals. Okay, does that make sense so far? So, what are we interested in? Who, what, why? Who is what individuals does the data describe and how many? How many is often a very important one. What is how many variables are there and what is the exact definition and what units? Okay. Why would be what is the reason the data was gathered? Why do I care? What is this useful for? Those are important questions we're trying to answer with statistics. So this one is going to come back a bunch and we'll see a more complete one. But this is a data of education. You see the state on the left. You see the region. Region is some arbitrary division of the country. The population of that state in thousands of people. So California has much more than 33,000 people, 33 million. This is also very old data. This is the data in this book is legitimate, but the book was published in 2002. So a lot of the data is not necessarily current or up to date, but it is realistic data. And it's very interest got a lot of interesting examples. You can see their average SAT verbal, average SAT math, the percent of the kids in that state that take the SAT, um, the percent no high school. I'm not sure what that is. I think that's the percent that don't graduate high school. Or it might be the percentage of population that doesn't have a high school diploma. And the teacher's pay. And we can analyze all diff kinds of different things about this data. Okay. A distribution of the variables tells us what values the variables take and how often it takes them. The why for the above data might be, does teachers' pay affect the education kids get? What it doesn't necessarily account for is it's a lot cheaper to live in Idaho than it is in California. The idea with teachers' pay would be that if you pay more, you get better teachers. Maybe sometimes maybe true, sometimes not. Um, The examination of what we're doing is called exploratory data analysis. We're essentially exploring our data to see if we see anything. Okay? To look for patterns that might be meaningful. So, if you'll notice with this book, I'm just going to assign problem numbers like 1.1, 1.2. They're scattered throughout the chapter. They do go in order. So they're just kind of mixed into the chapter. You just have to go through and find them. I will post the book on Google Classroom after we're done with the lesson. Or I will post scans of different chapters. So, displaying this data with distributions. So here we have the most popular soft drink. Coca-Cola, Pepsi, Dr. Pepper. This is most popular cola brands. National Beverage, RC, and other. What?
No.
RC? Apparently it wasn't very popular in 1999.
I swear. What is Apple?
What? What one?
The Royal Crown is like the thing.
Royal Crown is an alcohol, but RC, well, Crown Royal, I think, is an
Oh,
alcohol.
okay, gotcha.
RC, Royal Crown, I guess is just RC, and that is a RC Cola. The company might make other alcoholic drinks. I think it's Crown Royal you're thinking of. So, if we want to look at this, we can construct a bar graph. Now, there's two very important types of data here. Type 1 is numerical, or quantitative, right? You've learned that before? What's the other type you've learned? Qualitative, which you can't really do much statistical analysis on. It has value for things. The type you haven't learned is categorical. And this is categorized by the soda brand. In 1999, I'm not sure how many different flavors of Coke there were, but I'm sure there was cherry. I'm sure they're grouping Coke and Cherry Coke into the category Coke. They might have had Lime Coke, but I don't think that was out in 99. Um, Cherry Pepsi. I'm not sure what other ones there was. Hmm. I don't know what Cadbury is, and I was alive then.
Is that the company who makes that?
Might be, or it might have been who it was. So, a bar chart. You guys all know how to make a bar chart, right? Notice that the bar chart, they did the cases sold. The pie chart, they did the percent of market share. Do you know how they got percent of market share? They added them all up to get N. Okay. And then you just do this divided by the total number of cases sold. And our bar chart and clearly shows that Coke is winning, Pepsi's in second, Dr. Pepper's in third, and everything else is pretty small. Our pie chart also shows that on market shares. Again, Coke is not quite half, but it's close to half. You could not tell if Coke is half from the bar chart, could you? You could tell it's winning. So each different chart tells you different things. The bar graph or a pie chart. Do you guys also know what a histogram is? Do you know the difference between a histogram and a bar chart? It's a range. So the easy way I think of it is the bar chart is categorical on the x-axis. Whether those categories are, so you've thought of like five-star rating, right? On, you know, Yelp or Google or whatever. You can call that 1 through 5. You can think of that as numerical, but it's really almost more categories. Because have you ever also seen a survey where it's likely, extremely likely, neutral, not likely, extremely unlikely? Is that a 1 through 5 rating? Essentially, it's essentially the same thing. Um, so there's a lot of different things that could be translated. Depending on what you're doing with that 1 through 5 rating, you can treat it like numerical or categorical. Okay. So, do you wear a seatbelt? In 1998, the National Highway Traffic Safety Administration conducted a study, and they did it based on regions. The Midwest is in the Midwest of the Northeast does not really wear their seatbelts. I mean, I was in the Midwest in 98. I did not know it was that low. I knew people didn't wear their seatbelts, but that's like 37% of people didn't wear a seatbelt. So a third of people. My parents made me wear a seatbelt. I just learned. Um, so this again, this our representation says the South and West are basically equal. Northeast and Midwest are pretty close with I can tell Midwest is slightly less. Dot plots. Do you guys know what a dot plot is? So this is a number of goals scored in the California Southern Section Division 5 high school soccer playoffs. I believe this is total numbers per game. What does the dot plot show us? Correct. It also shows us that generally less goals were scored, right? As a general trend, we could see that the graph is kind of going like this. Maybe that's not the greatest shape of it, but because this is a small data set, if I did this for thousands of games, 4 would be more common than 5, right? 2 would be more common than 3. But I can see this generally decreasing amount. Okay. When you construct a dot plot, you put values on the x-axis and you put a dot for everyone that's there. Hey, everybody think they can make that? I told you today was easy. Yeah. What are we interested in? These are the interesting pieces of a distribution of data, the center and spread, and the shape. Okay? We'll talk about shape. Center, measures of center. Mean, median, mode. Anybody know the measures of spread? Standard deviation, interquartile range. Okay? We'll calculate all of those on Thursday. Or mostly we'll let our calculator calculate them for us. Because standard deviation is a pain in the butt. Um, an outlier. An outlier is an individual observation that falls outside the overall pattern of the graph. We'll talk about how to find outliers. There's a specific definition that you need to use. Okay? To determine if something is far enough out to be an outlier. Those that took integrated one with Mr. Klein or I learned this. That's 3 of you.
I don't remember that.
You didn't take integrated one with us. You took integrated 2. Okay. Anybody know what a stem and leaf plot is? I think we're gonna do a splits. Well, I'll just do an easy one. I think they do a split one later. So what's on the left is going to be the tens column. And I'm not going to get these in order. So this means 2, 0, 1, 5, 2, 3. So I'm going down, I'm taking this value, then 115, 23, 2, 3, 29, 23, 15. Now I've got another 23, so I put another 3 in the 2 column, or the 2 row. 31, 28. Does that make sense how I'm doing this? A stem and leaf plot is good for showing us shape. Okay. I'm going to skip ahead to where the book has them made. So here's the stem and leaf plot. This is not proper. A proper stem and leaf plot should have this row listed numerically, all of these rows listed numerically. Okay. So in proper order, it should go 0, all the 3s, then the 4s, then the 5s, 6s, 7s, 8s, and 9s. That makes sense. So you should rearrange it. So here's the proper one. This uses what's called a split stem. One of the most important things is they've got 2 different 2s here, right? The first half of the 2s are 0, 1, 2, 3, 4. You can split your stems as long as each stem is equal in size. So you cannot split tens into thirds or fourths. Okay? Does that make sense? And what this shows us is the general shape of the distribution. This one shows it a little better. Um, okay. Usually we'll think of distribution shapes like this, but with the stem and leaf plot, it's turned on its side. So here we've got another dot plot. What's the problem with this dot plot?
Uh, 3 categories. And their plots are all weird and
Okay. like there's so much variety, right? There's not, you've only got three that's got two. So dot plot is probably not the best representation for this data. The stem and leaf, how did they do this? Um, the leaf unit is the hundredths. Okay, so 15 is going to be 1.52. That makes sense. And then this number over here is actually, I don't know what that, oh, this is the total count of this many or below. So this is the cumulative count. I've had one here, I've had two by this point. Two plus three is five, five plus two is seven. Okay. This is the middle's here in the 1, 4. This is the cumulative count from the other end. So I know I've got 14 to here. If I wanted to find like a median, I've got 14 there and 14 above, right? So if I've only got 13 below, I'll cross out this to make it 14. The median is going to be the average of those two. 1.45. We'll go through that more tomorrow or Thursday when we actually calculate things like mean, median. We don't calculate mode really, but we'll talk about it. Um, this book gives you a lot of stats software outputs. You do need to be familiar with reading them. Your calculator will give you its own. You'll need to be familiar with reading some other ones too. Okay. And finding what you're looking for. No. Then I changed my mind. Yeah. Nope, you don't. I planned out till Christmas, and I'm just giving you one big test on chapters 1, 2, 3, and a little bit of we're doing a 4. Ha. So you'll not love that test because it's kind of long. It's going to be like 10 or 12 pages. 10 or 12. No, it might be 13.
Like multiple choice questions.
There are multiple choice questions. So I'm going to give you the chapter 1 test, chapter 2 test, chapter 3 test, and I'll give you a quiz out of what we do in chapter 4. But the multiple choice are honestly some of the hardest ones on there. Yeah, it's the Monday before you have break, Christmas break. So, displaying quantitative variables with histograms. Histograms, you're grouping together a certain data range, right? And we call that bin size. Okay? Let's talk about how to make this on your graphing calculator. Okay? So, you need to go open your graphing calculator, go to a list and spreadsheet.
But run the extra room.
Yeah, there should be one by my desk area. So I add a list and spreadsheet. I'm just going to put age in. You may want to start saving documents when we do statistics because some of the questions ask you to reuse the data that we'll have used in class, or they'll ask you to use data you used in a different question. So I need you guys to go ahead and enter these. Okay?
Just the age.
Just the age. Okay, I froze it on the screen. I'm going to go ahead and enter them myself. This is the ages the presidents were inaugurated at. It is useful to potentially have a count of how many people there are for presidents. You should have 43 when you get to the end. Do you have the right number?
Yeah, 942.
Okay.
Oh, well, there's nine.
Yeah. So one thing that I'm doing is checking as I go that I hit the bottom of the column at 15, 30, because entering the data will lead to wrong answers. Okay. So we have all of our data entered. To make a graph, we do add page and we add a data and statistics. We put our variable on the x-axis, age, and it will default make us a dot plot. This is not particularly bad data for a dot plot because everything's rounded to the nearest year, right? We just measure age by the nearest year. If we want to change, though, to a histogram, we're going to go Menu, Analyze, or Plot Type, Histogram. Now, this does not look like the histogram that the book shows you. The histogram that the book shows you, to do that, you need to go Histogram Scale, or bins. Let's start with bin settings. Equal bin widths by 5. The alignment is where do you starting from? Histogram properties. Notice it's going right off my thing. Um, Window, yeah. Okay, there we go. Usually it'll redo it when you change, if you just like re-add the X variable, it'll rescale it, but it didn't. So I zoomed out. This shows me a nice histogram. Looks pretty symmetric, doesn't it? Shapes we're going to talk about are symmetric, skewed left, and skewed right.
Oh, is this a bell curve?
Symmetric, the bell curve is symmetric. It does not have to be a bell curve to be symmetric, but that is generally what we call symmetric. Okay. This book has lots of t nice technology toolboxes on how to do this on the TI-83, which is the 84, and the TI-89, which is the very old, hard to use version of the CAS. Okay. So shape. Symmetric is anything that is symmetric. There's a shape that we don't often use, but this is called uniform. Everything's equally likely. Okay.
Oh, that's Granford.
So rolling a dice, you'd get a uniform distribution of 1 through 6. Does that make sense? Symmetric looks like anything that's symmetric. Uniform is symmetric. This is skewed. Anybody know which way it's skewed? Left. Tails on the left. It's about the direction of the tail. That's not intuitive. Okay. Basically, what it means is your big chunk of your data is here, but this one, the stuff that's further away is pulled towards the left. Okay. You will need to be able to identify those shapes from histograms and stem and leaf plots and dot plots. As you're all going, okay, that doesn't sound that hard. So what shape is this data?
Symmetrical bell curve.
That's roughly symmetrical, right? Just call it symmetric. You don't need to say anything about bell curve. What about the one below it? Skewed right.
You lost my touch.
Okay, last thing we're going to talk about is relative versus cumulative frequencies, percentiles, and ogives. Yes, an ogive is a type of graph.
That's it. Reason for my last name was tweeting about that.
You will get to degrees of freedom, but not till chapter 11? Uh-huh. I don't know. I've never done it in this order. My goal is you'll finish the test 2 weeks before spring break, but that might be optimistic. You're gonna have to be done before spring break because you have mock exams the week after. Okay, do you guys know what percentile is? When you get your percentile rank on, say, your SAT score. Say you rank 80th percentile, what does that mean? You scored better than 80%. Not that you scored worse than 80%. And this is one of the funniest things. So I ran a time in college. Ran a 35:12 in the 10K. So that's like a 17:36 5K. Twice without stopping. That was good enough for 33rd percentile. I beat about a third of the people. It means 2/3 of the people beat me. And you like it's kind of funny just when you think of percentile. And percentile, like SAT percentile, if you being a good student, you score a good percentile, usually, right? Now, if you look at your percentile when you go and you apply to Stanford, All of a sudden your percentile looks really bad, doesn't it? Yeah, you went from 95th percentile to 7th. Or something like that. 95th nationally too. So, here we have a question, was Bill Clinton a young president? We are using our graph from before, okay? If we want to look back at that data, we can see that Clinton was inaugurated when he was 46. Okay? That is kind of young, yeah. So, what we can do is construct an ogive or a relative cumulative frequency graph. Okay? To get these categories, now they're just putting them in the categories, right? So essentially, we made our histogram by hand. We could just order the graph because he was 46. I think he's the third youngest. But if you're looking at it from the graph's perspective, you get a frequency of 2 in the 40 to 44 column. You get a frequency of 6 in the 45 to 50 column, which is really 45 to 49, right? Because 50 goes to the next column. That makes sense. But if you're 49 in 363 days, you're 49. So what we're doing here is we're calculating the cumulative frequency. And then we're putting it into a percent by dividing it by the 43 presidents that had been inaugurated when this data was collected. We have since had a very odd way of only 4. Because Trump is the only president to have been elected, not elected, and elected again. Was there? But wasn't that like, yeah, that was a long, long time ago. I think Trump's one of the only ones that has run after losing. Okay. I was like, yeah. So, so an ogive is essentially this relative cumulative frequency graph. Okay? So it looks like this. At 40, there was no one in the column below that, right? By 45, we're up to this percentage, which I think is about 5%. Then we're up to about 18.6. Clinton falls into this category, so yes, he was a relatively young president. Okay. Notice it goes up steeply. This was our high point in our histogram. We look at our histogram. Where you've got a lot is where it's steepest on the ogive. Where you have a less, it's not as steep. Okay. And an ogive must always end at 100%. We've accounted for all of our data. We have 2 presidents that were older than 70 that have been inaugurated this century. I mean, people live longer. Time plots. A time plot uses time on the x-axis. Um, so if you look at orange price, all fruit has seasonal variation in the prices, right? So this is the price plotted over time. When it's spiked high, it's, out of season. When it's low, it's right at harvest season. And you can see The time plot shows us that this repeats every year. What is the general trend showing over the 90s of the prices of oranges? It's going up. The high price is going up and the low price is going up. But there's quite a bit of seasonal variation. And that's where a time plot shows us. Okay? That's section 1.1. How was that for a math lesson? Enjoy it. You've got a few weeks of it.